हेलो डियर स्टूडेंट्स, मैं आपका फिजिक्स मेंटर प्रकाश रंजन। सो वेलकम टू माय चैनल इम्पल्स जेई फॉर लर्निंग फिजिक्स. So today I am going to discuss the problem from Pathfinder physics book from Kinematics, in which we will discuss the concept of curvilinear motion during solving this question. I hope you all will be doing good in physics and आप लोग कर्वलिनियर मोशन को काइनेमेटिक्स में पढ़ लिए होंगे. So just you watch this lecture how we are going to implement the concept of curvilinear motion during solving this question. So this is the 40 number questions in Build Up Your Understanding in Kinematics of Pathfinder book. It's a given that a straight track is tangent to a circular track of radius r. Two material points A and B starts simultaneously from the common point of the tracks. The point A moves with uniform velocity u on the straight track, whereas the point B on the circular track always keeping itself collinear with the center of circular track and the point A. It is shown in the figure also. It is always maintaining along the same line. If B is here, then A will be here. So we need to find the suitable expression for the magnitude of acceleration of the point B when it is at angular position theta as shown in the figure. So I am going to draw this figure once again. So this is the circle. And say this is the line on which A is moving. This is the center. This radius is given R. And B is somewhere lying on this circle. So what we can say, if A is here, then B and A will be always collinear, then B will be moved to somewhere, say B prime, like this. And say this is goes to somewhere A prime. You can say this is the situation at any time t, and say this is the situation of any time t plus dt. So what we can say, during this interval of time, this A would have been moved a distance of u dt. Say this angle is theta and this angle is d theta. So if you try to find out the area of this triangle, area of triangle O, A and A prime, then this can be written as half of mod of OA vector cross AA vector with the help of vector. So say this is one vector and this is your another vector. So angle between them is how much? This angle will be 90 minus theta, because from the vertical the angle is, this angle is theta. So this would be 90 minus theta. So angle between these two vectors is 90 minus theta. So in a scalar form we can write this is simply OA A prime sine of 90 minus theta means cos theta. And if we try to find out the values of OA in terms of this theta and the R, then OA can be written as R by cos theta in this triangle. And your A prime is nothing but in this interval of dt, distance traveled by this point A. So if we substitute the value here, then we are getting r by cos theta udt times cos theta. So this get cancelled out. Now we need to find out the relation in terms of d theta so that we can find the rate at which this position vector is going to rotate. And since A and B is collinear, so we can say angular velocity of B and A is going to be same. So the another expression that we can find for the area of the sector, because if we equate these two area, then area remains the same. So from area of sector we can say OAA prime can be written as half times this radius is r sec theta, means r by cos theta square, and times angle subtended at its center is nothing but d theta. So these two must be same. So we can write this is coming half r u dt is equals to half r square cos square theta d theta. So these r get cancelled out. So d theta by dt would be u cos theta by r. This is omega at this given instant. You can say when it is making angle theta at any time t. So omega is a function of t, we can say. So since theta is going to change with the time, so this omega is not constant, definitely it is going to vary. We can find the alpha also. But this is the one way of approach that is complete your mathematical. The second approach that I am going to tell you is completely based on your curvilinear motion classes that I have told in the class. So if you try to implement those concepts, then we don't need to do all this much of calculation. Directly we can get this result. How? So let's see. The second approach is, say this is your O point, say its center, and say this is point B, and say this is your A, and A is going with you, right? This angle is theta. So you can treat this OA as a one position vector, and you know well perpendicular to this we write VT. So if this angle is theta, so this angle will be also theta, means this angle is your. So if you find this angle, so this angle is your theta. So this angle will be also theta, right? So here Vt we can write that is coming u cos theta. And this OA is already we have calculated r by cos theta, and we know that omega is Vt by r. That is nothing but Vt value is u cos theta by r by cos theta. So we are getting u cos squared theta by r, the same result. But here the calculation is lengthy. Okay, but in both the ways you can solve. Once we have this omega, we can find the alpha also, and this alpha can be written as d omega by dt. That we can write minus 2u cos theta sin theta by r times omega. So if we substitute the value of omega, then what we can write? 2u cos theta sin theta by r with this negative sign times omega. That omega was this value. u cos square theta by r, right? So if we simplify, then this is coming 2u square cos q theta sin theta by r square. So now we can write centripetal acceleration, or you can say radial acceleration. Then we write this as a omega square r. And the omega value we have u cos square theta by r of a square times r, which we are getting u square cos 4 theta by r. This is this centripetal, or you can say radial acceleration. Similarly, tangential acceleration we can write as alpha times r, which is nothing but simply I am taking the absolute value modulus. So negative gives that only the direction. So I am not taking negative into this account here. So we can write 2u square cos q theta sin theta by r. So net acceleration A at this instant can be written as a square r plus a square t. So this is u square cos 4 theta by r square of at value is 2u square cos q theta sin theta of whole square of a square root. You can take common outside. Sorry, here a square will be not there. So now we can take the common terms outside of this square root, and we can write this as u square by r cos q theta 1 plus 3 sin square theta. This is the required result. So I hope you all will be agreed with the concept of curvilinear motion that I have used during solving this question. So this is all for the day. Thank you everyone. Thank you for watching my channel.